we already did. So this mainly used for whether the statistical test is passed or not. That is the main motto of the hypothesis testing. There we seen that jet test and a t test, okay, and the chi-square test and ANOVA test, like we have it, right? I think we are not completed those things. I will try to I will try to finish it by this particular session, okay? And yeah, so let's see. So at what area and even though you can go for the jet test or even though we can go for t test, there is a three type of tests are there under the jet test, under the t test. One is the one tail and two tail, and from the one tail itself, left tail and the right tail, we have it actually, okay? So based upon the p value, we are going to be deciding that whether the hypothesis testing is passed or not. See how we this particular p-value can be calculated depends upon that particular statistics test we are using, okay? Yeah, if in case this is the p-value will be it's a cutoff value. If it is a less than the or less than or equal to 0.05, that means we are going to be rejecting the null hypo, okay? If it is more than the 0.05, that we should go for accepting the null hypo, okay? So this is the p-value for t-test. How we can able to calculate the p-value in t-test? Just p-value for jet test is a curve. This is the p-value for a jet test is a curve. The p-value for the t-test
class में
t curve. What is that? Hello?
क्या हो गया देखो
No.
ठीक है तू आराम कर फिर
Yeah. So this is the p-value. In case of jet test, we are calling it say jet curve. Okay. In case of p-value for the t-test, it will be the t-curve area actually. Okay. So this is the following figure illustrate the three different cases. One is the one-tailed t-test is n-1. That means df. Df means it's a degree of freedom. The number of degree of freedom for the one sample t-test is n-1. Okay. So this is the right side, right? So calculated the t-value if it is the one-tailed test, okay, one sample t-test or one tail, whatever it is. So this will be the upper tail test actually, because of we are going to be taking the data at the right side of thing, so that so we have to calculate the p-value equal to area in upper tile actually. So the p-value will comes to this particular area actually when it is the upper tile. So the p-value can be lower tail whenever the lower tail t-test, okay? So this thing will be less than this particular. So area in lower tail actually, this particular area you will be getting actually, okay? This coming to this particular two things actually, HA contains the inequality. It's a greater than values, okay? This contains the less than values. HA in the sense alternate hypo contains the inequality, okay, but it will be less than actually. When we taking the p-value will be less than lower tail t-test. So when we are taking the two tails, that particular situation, we need to take the two tails and we need to sum off it actually, okay? So that when we are taking the two tail, okay, then we have an option for this is the HA is inequality. So you are not saying that whether it is a greater than or less than. We are saying that it's a not equal. But when you are taking this particular upper tail or lower tail, we are giving the some kind of comparison greater than or less than for your alternate hypo. Okay. So this is the small figure for understanding the t-value at a t-test. P-value at t-test. When you're taking the p-value at a jet test, this is also same thing where actually. So p-value area in upper tail when you are taking the jet value, and lower tail. So this particular thing we will be considered actually. So here there is some kind of formulas also he mentioned over here. So this is the thing 1 minus xi z, Okay, this is the lower tile. We are taking the xyz, exactly xyz. But when you're taking the upper tile, then 1 minus xyz. Okay, but when you're taking the two tile, when we are taking the two tile, okay, yeah. So this will be 2 into 1 minus xyz. Xyz. Okay, this is the two tiles we need to do that. Sum of the this particular two tiles actually. Okay, that's pretty cool. This is the z test and a t test, and this is the p values. Both the scenarios will be the same. So how you calculated the p value in t test, and the same way we can able to calculate the p value at a test, z test as well. Okay, so here we have some kind of examples are there. The silicon vapors target thickness. So this is the one sensor actually. So silicon vapors is one of the sensor. The thickness of integrated circuit is 245 micro mm. Okay, the silicon vapor target thickness is, the integrated circuit thickness is 245. So this is the statement. And so here there is a 50 samples are there. Sample of 50 vapors is chosen. That means you are taking the 50 samples. That means my n value is 50. Try to understand when you are reading the statement or problem, we need to find out the we need to find out the terms actually. So this is the 245. This will be what? This is your mu. What it is? This is your alternate hypothesis average value. This is your mean value. Okay, so anyway, this is your 50 samples, and the thickness of each one is determined, the resulting in a sample mean thickness. That means this is the mean sample. So whatever the 50 vapors we consider, that 50 vapors, the average value is 246 plus 18, and the sample standard deviation is, this is the standard deviation, this is the mean. Whenever we know the sample deviation, whenever we know the standard deviation, whenever you know the mean value, okay, sample mean value and the mean value, whenever we know the population mean value, okay, so definitely we can able, and moreover the jet, if you have the samples are more than the 50, then we can able to go for jet test. Okay, does this suggest that actual average of thickness something more than the target value? So that means here this is your true average value, but this will be little bit of less, right? So suggests that actual average thickness is something other than that target value. Okay, so yes, this is the inequality is there. So this is the parameter for interest. So here, this is the mean is, this is the mean is, it's your population mean. This is mean is population mean. And so we have to suggest that my population mean is not equal to 245. This is the not equal to 245 that we need to be considered, because of the mean is 245, right? So the population mean is 245. That is the alternate hypo. Okay, because of this is your assumption, and alternate hypo, it is not equal to 245, right? And for that one I can able to go for the jet test. I can do that. For the jet test, we have a formula is, it's x bar minus, that means sample mean minus population mean by standard deviation by the square root of the n. Okay, that means population size. So when we have calculated this particular value, x bar is 246 plus, here we can consider 246 plus 18. This is sample mean. This is population mean. This is your sample mean. So in this particular problem statement they given, this is your population mean, this is your standard deviation, this is your n value, so this is the final z value. So we calculated the z value. From this particular z value, we have to go for find out the p value. So when we consider the p value, when you know the p value, if it is a less than the 0.05, so we need to reject. That means we have to go for accepting this one. Okay, if it is greater than 0.05, so we should accept this one, we need to reject this one. That's a simple thing. So we calculated the Z value based upon the values what we have it, and to calculate it, the p-value, whether you're taking the two samples or one sample, that's your choice actually. So when we are taking the two sample, this is the two sample, the formula is it's a 2 into 1 minus 1 minus what is that, 1 minus what, it's a jz, right? So here the 2 is it's a 2 and 1 minus it's 1 minus, okay, what is the value we got it, it's a 232, is it correct or not? 1 minus 2.32. So guys, can anyone tell me what is the value of this one? Is it correct or not? We are getting negative value. Just a moment. Clear all drawings. So we have that Z value you calculated, xi of Z, right? Z value how much? It's a 2.32. So this is the value we need to find out. Xi of Z we need to calculate it. How should I calculate that? How should I calculate it, this particular xi z? How should I calculate it? How should we calculate it? So for this one, we have the jet table is there. I can show you jet table in the Google. Jet table. So guys, this is a jet table is always similar. It's always same. So fine. Jet table. So just jet table. It's a two-tailed jet table, right? Just you can say that two-tailed jet table. Yeah. Okay, fine. So what is the value we got it?
2.32.
2 point
2.32.
2.32. So 2.32. Just 1 minute. So here the calculation part. So to 0 0.0204 by 2 0.01 0.98. 0.098. 2 point.
It's 2.32.
2.32. 2.32, right? So you can see this table. So population mean how much? This is Z value, Z calculator. It's a Z calculator. You can go through. There is some websites also there, jettable.com. So there we can able to give the population mean and the standard deviation and the value of it. You can give it. But anyway, you have that Z value, right? So the Z value is we already calculated. It's a 2.32. So 2.32 in the sense.
The third digit would be available in the columns, and the first digit would be 2 digits will be in the rows.
So see
So
this
2.3 and the third column value 0.983.
So 0.98.
983.
Yes, it's 0.9.
0.98983.
0.98983, right?
Yeah.
Yes, this one 0.02. So this is the value, right?
Yeah.
So this is the value we need to consider it. Okay. So yeah. So yeah, fine. So 0.98983, that value we need to submit over here. We'll be getting the 0.0204. Okay. Got it? So fine. So this is the value we got it. So with the p value, whether it is the less than 0.05 or greater than 0.05. The p value is the less than 0.05 or greater than 0.05. This will be the less than the 0.05, right? So conclusion is using significant level of 0.01. So we would not. Oh, for two-tailed test, we are taking the 0.01 for significant level of 0.01.
No, why? Like that's a defined one, right? Like you can define the significance level. Just that's your confidence interval kind of value.
Yeah,
When
so
you're defining the
we need to consider it again, right?
yeah, you can like the problem statement states that the significance value is 0.01 if it is stating,
yeah,
or else you can consider your own significance value. So you have considered your own significance value, that's a 0.01.
0.01. So
So
you're
based on that hypothesis, you are rejecting. You cannot reject the null hypothesis. That
not
means
reject the null hypo. So that means the mean
your
value will be
population mean is 245.
245.
True.
It's a true value. So we need to think about, because of till here everything will be similar, okay? But when we are taking the p value and condition what we are choosing, that will be the little bit tricky. So we need to focus on this particular thing as well. So is I would like to go with some kind of standard thing. Otherwise, problem to problem, it will be very difficult for us. Okay, actually, the p value will be the greater than. I think that will be the that is some tricky is there. So why it is happening, I also need to check it out, because of it's not my example, right? So I'm considering from somewhere else. Yeah. So in the meanwhile, let's go with the t-test actually. So coming to the t-test, it is also very similar to that one. This is the formula for t-distribution similar for normal distribution. And so mainly this can be used for when we have that less than 30 samples, then we need to consider. Okay. So for the t table, so we have to go for find out the t value. Okay, for example, the degree of freedom is so degree of freedom in the sense your n value. For example, you can take that your n value, okay, 20 or 10 or 11. So the degree of freedom will be 10 actually. Okay, that means number of samples are 11, then degree of freedom will be 10. So the value can be coming from this particular row. Okay, in the meanwhile, how the jet table is there, in the meanwhile we have the two table also there. Okay, so if you are taking that one tile or two tile depends on your data, so that particular corresponding value we need to calculate it, that value we just provided. Okay, so if this is the thing will be, if the t value is more than what means the p value less. Yeah, so this thing also we can easily figure out. So this is the t value x minus mu by square s by square root of n. This is your t value in the just how the z is there in the same way. Okay, but there the number of samples are less than the 30. Okay, so the formula how the z test is there, z test formula is there, right? The same formula we should use it. Okay, and but thing is that here the number of samples will be not more than 30. Okay, so here we calculated the same scenario, we just need to calculate it. Here 14 minus 130 and minus 0. It's a t test 6. So you can easily calculate it. Here we can have some kind of this or things we given over here, and when to use the t-test and when to use z-test also we have that beautiful diagram over here. Do you know the population standard deviation? Yes, if you know the population standard deviation, if you know, then is the sample size is above 30 or less than 30. If above 30, then we can able to go for z-score. If in case if you don't know the standard deviation of the population, then we can able to go for the directly t score actually. Okay, or else if you know the standard deviation, then your sample size is less than the 30, then we can able to go for t square. So that means most of the time the t score will be helpful if and only if we have that sometimes we can see, guys, if you don't know the standard deviation, that situation also we can, even you have that more than 30 records also, sometimes you should use the t score. And when we can use it, when we don't know the sample population or standard deviation. So the jet test tell you how many standard deviations away from the mean. So because of jet value, which is the middle point, that the mean value can be the 0. So this is the 1 sigma, that means 1 standard deviation. This is 2 standard deviation. This is 3 standard deviation. Whenever we consider the normal distribution, when we are considering the normal distribution, okay, so the most 65% of the data, 65% of the data fall in between 1 standard deviation, and 95% of the data will be fall in between two standard deviation. So 99% of the data will be fall in between the 3 standard deviation. This is the thing will be we can consider it's a outliers, guys. Okay, this is the portion we can consider it's a outliers. We don't need to consider those values. Is it clear? So this is the thing we are calling it's the empirical formula. Those things we are calling it's the empirical values. So that's very pretty cool that you understood. There is a two type of errors are there. There are two possible errors in this particular situation. Type 1 error, type 2 error. Type 1 error occurs when we reject the null hypothesis. Whenever we reject the null hypothesis, type 1 errors occurs when we jury convince an innocent person. You understood, right? False positive error. False positive error. The null hypothesis is true. A type 1 error occurs, but it's rejected. Actually, the null hypothesis need to be rejected, but your test is saying that it was true. So that this kind of error we are getting, this is the false positive error. So type 2 error we are getting when the null hypothesis is not rejected. So when we are rejecting the null hypothesis, then we are getting the type 1 error. When we are not rejecting the null hypothesis, that means we are accepting the null hypothesis. That particular situation, we are getting the type 2 error. This type 2 errors is false negative, whereas a test results indicating that condition is failed, it was successful actually. Okay. So this is the two types of errors it can be getting. It depends upon whether it is that particular value. If you're not giving the proper values, then particular situation we are getting this particular error actually the null hypothesis need to be accepted, but that particular situation you are rejected actually, then that error we are calling it's a type 1 error. Actually we need to reject the null hypothesis, but we are not rejected that particular situation, we are getting the type 2 error. Okay. So yeah, type 1 error and type 2 error, fail to reject the H4, correction, conclusion. So this is the table we can try to understood, guys. Yeah, H0 true, that means you should accepting the null hypo, fail to reject, correct conclusion. Okay, and that situation we are getting the, so if we are accepting the alternate hypo, then it will be the type 2 error. Reject the H0, reject the H0, but actually we need to accept the H0, but that particular situation we are getting the null type 1 error. So but if you're rejecting the H0, that means we're accepting the H1 H0 alternate type, right? Then that is the correct conclusion. Okay, these two situations are correct conclusions, but these situations are failed situation. So that is the type error, type 1 error, type 2 error. Okay. Yep. So this is what, and you can easily understand this particular document. So type 1 error, type 2 error. Okay. And Bayes theorem actually. So Bayes theorem is, it was very simple thing. This is a conditional probability thing. Okay, so like ak by b, this k will be the constant. So this is the by, right? So it's the condition ak condition b, then that particular situation p, probability of a interception b by, okay, probability of, this is the k is nothing but it's a number of elements. Okay, so these things we can have it, it's a Bayesian theorem. So will Bayesian theorem we have it for Bayesian probability distribution we can understand. Yes, this is very very important, guys. Conditional intervals. This is the CI will be very very important. This can help you whenever you know the sample deviation, standard sample mean and sample standard, whatever it is, we need to go for estimating the population. You know only sample data, but we don't know the population data, so we need to we need to estimate the population thing. Then this is the CI can help us. It is the range within the expect population parameter. So this is the CI will give you this particular range, that particular value can be following it. This is the CI around the sample statistic is computed in such a way that it was the specific chance containing the value of the corresponding population parameter. It indicates that the range likely contains the true population parameter, so that say focus on the population. They often used the marginal error. It is denoted by the 1 by alpha. Alpha is the value in between the 0 to 1. This is called confidential intervals. Okay. So if you say alpha is 10% and 90% is the parameter. So 10% and 90% is the parameter inside of the intervals actually. So like if we are using the 90% sure, then alpha is 5% actually. Okay. So it can be computed with help of the formula given. So this is x bar. X bar means it's a mean of mean minus this is z alpha by 2 into sigma by, okay, square root of n comma x bar minus z alpha by 2, okay, into sigma by square root of n. This is the formula, guys. This is the interval. This is the positive this is lower interval, this is upper interval. Okay. So here the common CI is 90%, 95%, 99% with respect of the alpha ways. For example, you want to find out the 90% of the data. 90%, 95% of the data, 99% of the data, that particular situation, we need to consider the alpha values are, it's a 1 minus this value, this will be the 10% of alpha, this is 5% of alpha, 95%, right? So that 5%, 99 in the sense 1% of alpha. So we can say that alpha value is 0.1% and 0.1%. It's not percent, 0.1. This is 0.05. This is 0.01. This is the alpha values, guys. Okay. So the CA intervals, the marginal error is, so 95% of the confidence intervals occurs in the sample of 330.6. The sample mean is 330.6. So I would like to go with the 95% of the marginal population mean I want to be calculated. Okay. So it was very simple. So 336 plus or minus 95% of the intervals we need to calculate it. Okay. So CA is 1, which is alpha, then which is the alpha level. Maximum value is 1 actually. And 0, if 0.05 is the level of significance, that means 95% of the corresponding CA actually. Okay. So when we are taking the alpha value is 0.05, that means 95% significant. If you're taking the alpha value is less 0.01, then 99% will be the significant actually. Okay. So here some kind of values, if the significant alpha level is higher than the p value, so whatever the alpha value we consider, and meanwhile we calculated the p value, so this alpha value is higher than the p value, then we can say that hypothesis can be significantly correct actually. Understood? So here we have an alpha value. This is alpha value and corresponding p value. If it is a more, the alpha value is more than the p value, then we can say that hypothesis can be significantly correct. So whatever the calculations we calculated, that will be the correct actually. If the null hypothesis value is not found in the confidence interval, then the result we are significant. Results are significantly significant, statistically significant. If alpha is higher than the p value, then hypothesis value will not found in the confidence intervals. So here we can see that answer. So we can have some examples so that you can understand. I think, yeah. So given the problem calculation, step 1, given the number of observations are n, the mean value standard deviation is s. So for example, number of observation they given 40, the mean value they given 175, and standard deviation is 20. So decided that the confidence interval 95%, 99%. So we have to find the z value for the corresponding intervals actually. So for 80% of the data, the z value is 1.82, and 85% of the data corresponding value is 1.142, and 95% of the data will be 1.96, guys. Okay, this is standard values. If you are taking the 95% of the data, then it will be the 1.96. If you are taking the 99%, then the corresponding z value is, it's a 2.576. Okay. So my z value is 95%, sorry, my alpha value is 95%, right? So that I can consider z value is 1.96. Use the z value in the formula of the confidence interval, x plus or minus z square root of n. So you calculated the z value, z into standard deviation by root n actually. So we have to calculate the z value. We already know the sample value, and we already know the standard deviation. You already know the n value. So this is the range the data can be following it. Okay. This is the way the confidence interval also will be considered. This is the confidence interval also we have to calculate it with the base of the z only. Okay. And next one is chi-square. So this is the chi-square is, this is the chi-square can be used for when your data will be the categorical data. Okay, when we have the data will be categorical data, the probability of statistics, the chi-square distribution, also chi-square or chi-square distribution with the degree of freedom is k, the distribution sum of the squares, k independent standard random variables actually. So x chi-square distribution, continuous probability distribution that widely used for statistical inference. The chi-square distribution related to standard normal distribution. If the normal, if the random variable z has the standard normal distribution, then z square and chi-square distribution is 1 degree of freedom actually. So Here, how we can able to calculate the z square in a P that we seen it over here. So for that one, we have the stats and the chi-square stats we can give you and degree of freedom, and we can give you this particular formula, then we can able to calculate it. And the PDF, the probability distribution function for the chi-square, this is the formula. So basically, this is the chi-square for the goodness of fit test actually. Chi-square test for the testing the goodness of fit. It is used to decide whether there is there any difference between the experimental value and expected theoretical value. Okay, what we are calculated, what we are thinking, that will be, is there any difference? The chi-square test is also written as chi-square test is any statistical hypothesis test, whereas the sampling distribution null f becomes true actually. So this is the formula. This is the O in the sense observed. Okay, this is the E in the sense expected. Okay, O observed frequency, E is the expected frequency. So this is the formula we can able to give you. So for example, when to use the which statistical distribution? For example, if we have the one sample, is the sample size is greater than sample. So we are taking the one sample data. So the sample data is the greater than 30. So you can go with is the parent population normally distributed. If the population is normally distributed, then no test is needed. The sample is normally distributed. Okay, then you can go with continuous with Z value. For example, so if your one sample test is the greater than 30, but your population is not normally distributed, it is unknown values, then we can able to go for apply the center limit theorem. Okay, after you are applying the center limit theorem, no test is needed. The sample is approximately normally distributed, so that we can able to go for Z test actually. Okay, and for example, if the sample is not more than the 30, then again we have the options are if the population is normally distributed. If the population is normally distributed, no test is required. The sample is normally distributed. Do you know the population variance? If you know the population variance, then we can able to go for the continuous Z test. For example, if you don't know the population variance, then we can able to go for the t test actually. Okay. For example, you're strongly believing that the population normally, if the parent population normally not distributed, so use a non-parametric test actually. Okay. So for example, if the population is, you don't know whether it is distributed or not, so that particular situation, normal to using the Wilk test. So this is the significant value. The p value is more than the 0.05. The sample is normally distributed. Then we can able to go for again population is variance if you know Z test. If you don't know t test actually. So for example, significantly the p value is less than 0.05. Then you can able to go for non-parametric test. Okay. So that will be the test we can able to use it. In the meanwhile, we have the ANOVA analysis. This is also very, very important. This can be helpful for when we can able to go for linear models actually. This is the parametrical test technique used to compare the data set. Whenever we have the two tests are there, that particular two sample data we have it, that particular two sample data set we need to be compared. Then we have the R.J. Fisher is the person he was invented this particular technique, so that we can able to say that it's the Fisher-Nova. Okay. Whenever we are going with this particular ANOVA test, we need to do some kind of assumptions actually. We need to do some kind of assumptions. The independent case assumption means the sample should be selected normally distributed. So here independence case assumption means that the sample should be selected randomly. The samples we need to select randomly, and there should be no pattern in the selection of the samples. And next one is normality. So first one is independent. Second one is the normality. Normality in the sense distribution of each group should be normal. So Kolmogorov, Semerov, and Shapiro-Vico tests may be used to confirm the normality of the group or not. See, how can you decide that whether the my particular data set is normally distributed or not? How can you decide it? There is some kind of Shapiro test and Kolmogorov test. These the two techniques can help you to decide it whether normally distributed or not. Homogeneity means between the groups. So when we are taking the two groups, whether there is homogeneity will be there or not, the variance must be the same to test the correlation between the group levels test to be. So when the correlation, the variance must be the same for the two things, then that way the homogeneity actually. Okay, so ANOVA has three types actually. So if you want to start to compare more than three groups based on the single factor, that it is known as the one-way analysis of variance, ANOVA, one-way analysis of variance. For example, if the mean output is three workers is compared whether they are same based on the working hours of the three workers or not. Okay, so try to understand if you start comparing the more than the three groups. Okay, in the one single factor, we are taking only one single factor, we are comparing the three groups. So for example, you're taking the three workers and they are working 3 hours or not. So that is only we are taking one factor and we are comparing that. That is one way of analysis of variance. So two way of analysis, when the factor variable is more than the factor variables. So here we are taking the single factor, but we are taking the factors are more than the two. It should to be two-way analysis of variance. For example, on working of condition hours, we compare whether not mean output three workers in the same. So K of analysis in the sense the factor variables are K. So that means we have the K number of conditions actually. KV analysis of variance. So this is the partition of variance of ANOVA, SST, the between the or SS stands for sum square actually, sum square between or sum square within. So this is the two things it can help you. So calculation of degree of freedom, it's a K minus 1. Degree of, so between, if you are taking the between, SS, sum square between if you are considering, so the degree of freedom is K minus 1. If you are taking the within, so N minus K. If you're taking the total, N minus 1, this is the degree of freedoms we need to be considered, depends upon the which sum square we are calculated. If your sum square you calculated between, so we can take the K minus 1. If you're taking the within in the with some range actually, so N minus K. If you're taking the overall, so N minus 1. So this is the sum square we can able to give you. So sum square between the variability because of interaction between these particular groups. Okay, sum square between sum of Ki whole square by N minus T square by N. So Y square, some formulas are there, mean square error, this is F value. So this is F value we can able to go for. If you take the ANOVA test directly, it can give you actually. So this is the F value. So ANOVA is nothing but this is the F value only. We have to calculate the F value. Okay. The proper way we have it to calculate the ANOVA. Yes. See guys, this ANOVA test and T test and jet test and this is the Shapiro test and the Kolmogorov test. This all the things we can able to see that in SPSS. Okay, sequential statistics software. I have it, that particular software we would like to calculate it. Okay, so this is the test we can able to use usually. So guys, this is the document I can able to share with you. Okay, whenever you free, you can able to go through that particular thing actually. So guys, I hope you understood, right? Is there any question regarding about this one? Once we can read this particular document and then come up with some doubts actually. Okay, so if and only if you understood, then we can able to check any kind of statistical test. Otherwise you can't do that actually. I hope you understood. We'll catch up in the Python class who are coming for Python. Okay, so guys, you can go through this particular document. It can help you a lot. So it was having the full intuition on this particular thing and the proper examples also there. Okay, so we can go through this particular thing and we'll come up with Python classes again. Okay, bye guys. See you. Take care. Is there any questions, Shivaram? Shivaram? Shivaram, is there any question? Okay guys, bye, take care.